Okay. So our first example. So I tried to list steps here. Now, we're not always going to use these steps. I'm not going to talk over you guys, okay? We're not always going to use these steps. So if we don't have that step, I'll just write none or skip, okay? And sometimes we use steps that aren't listed, but the steps that are on the inside of your journal are the most common steps, right? So the first one, I have 1/2 times the quantity, 40J plus 10 equals 15. So step number 1 says, hey, you should distribute. So I need to make this a little bit bigger so I can write on it. So I'm going to distribute. Remember that when I distribute, I kind of draw arrows over the top, because that means I'm doing what with the number outside? I'm multiplying it, yeah. So I'm going to say to myself, what is half of 40? 20, yeah, it's 20J. So 20J plus, what is half of 10? 5 equals 15. Okay. Step number 2 says, hey, you need to combine like terms. Like terms are terms that are on the same side of the equal sign. Well, I don't have a J, like another variable term on this equal side, like on the same side, and I don't have another constant. So there are no like terms. So I'm just going to write that. No like terms. There's nothing on the same side of the equal sign that I can combine. The step 3 says, hey, if you have variables on both sides, you need to move all the variables to one side and all the constants to the other. Well, I didn't put any of those in here because those are variables on both sides. That's a lesson all by itself, lesson 1.4. So I am just starting with the 20J plus 5 equals 15. So this says isolate the variable by adding or subtracting the constants. So I want you to think about, what is the opposite of plus 5? Minus 5. So whatever I do on one side, I have to do on the other side. So 20J equals 15 minus 5 is 10. Step number 5 says multiply or divide by the coefficient. So this says 20 times J equals 10. Well, the undo of multiply is divide. The undo of multiply is divide. So last question is, well, what's your final answer? Well, I have J equals 10 over 20. And that can be reduced because I can divide both of these by 10. Do you see how I just cross a 0 off of each? J equals 1/2. How do we feel about that? Good? Okay. Can I go all the way up to the top? Is everybody ready? Okay. Our next example has no distribution. So I'm just going to write, there's no distributing. There are no parentheses here for me to get rid of, and that's when we use distribute. And there are also no like terms. But, thank you, there's something that I have to do. I have to eliminate the fraction. Right? I have to get rid of that fraction. And I do that by multiplying by the denominator. Are you guys all right if I just write multiply by denom for denominator? So that equation is x minus 3 divided by 5 equals 6. I have to multiply by the denominator to get rid of that fraction. That wasn't one of the steps. It didn't say multiply by the denominator, right? Because that's not a common thing. So I'm going to multiply this side by 5 over 1, and I'm going to multiply this side by 5. Why do we do that? Because it lets us cancel out our denominator. So I'm left with x minus 3 equals 30. Now I'm on that step that says, hey, isolate the variable by adding or subtracting your constants. So what is the undo of minus 3? Plus 3. And when I do that, I have x equals 33. So I don't have anything to do here because x is already by itself. Just going to leave it blank and write x equals 33. Okay. Does that make sense? Okay. Mrs. Bischoff. Hey. Yes, I can. Thank you, ma'am. Maybe then go on down to tech. It's in library. They're going to issue your card. Alrighty. Are we good to go to the next one? Okay. So for this next one, I tried to make this one tough, and I had quite a bit of room in there to put a big equation. So the first thing says, hey, you have to distribute, right? Remember, distributing means you take the number outside of the parenthesis and you multiply it by both terms inside the parenthesis. On the second one, remember that the number outside of the parenthesis is a negative number. On the second grouping, the number outside of that parenthesis or that grouping is in fact negative. Do you guys see that? Okay. So what is half of 10x? 5x. Good job. And what is half of negative 8? Negative 4. Good job. What is negative 1/3? So a third of 6x. 2. And it's going to be negative, right? Because a positive times a negative is a negative. So negative 2x. Multiplying by a third is the same thing as dividing by 3. So 1/3 of 9 is what? Same thing as 9 divided by 3, which is 3. And a negative times a negative times a negative is a positive. But I also have this plus 4 equals 5. Whew, that's a lot. Okay. Step number 2 is talking about like terms. And there are a lot of like terms. So I'm going to rewrite this. And I'm going to underline the like constants. And I'm going to circle the like variable terms. So I have a 5x and a negative 2x that are going to have to be combined together. But I also have a negative 4, a positive 3, and a positive 4. They're going to have to be grouped together. Remember, like terms are on the same side of the equal sign. They're on the same side of the equal sign. You can't cross the equal. So let's see. What is 5x minus 2x? 3x. Good job. And what is negative 4 plus 3 plus 4? Do you guys see that you have a negative 4 and a positive 4? What do those do to each other?
Make positive 8.
What is, if I have 4 negatives, these are all negatives, and I have 4 positives, those do what to each other? They cancel each other out. So whenever I see something like that, I just kind of cross them out. So really all I have on that side is a plus 3 equals 5. Okay. We don't have any variables on the other side because we're not doing variables on both sides. That's not a lesson that we're ready for yet, I don't believe. We're going to hold off on that one. So I'm just going to rewrite that. So I have 3x plus 3 equals 5. So this step says, hey, you're trying to get the variable all by itself by moving the constant. A constant is just a number. So what number, what's the operation that I'm going to use to move away that constant? Addition? Subtraction. Good job. So I'm going to take that plus 3, and in order to get rid of it, I have to cancel it out or subtract it. So this cancels out, and I have 3x equals 2. So that brings me to this step. It says, hey, guess what? You're going to multiply or divide by the coefficient. That's the number attached to the variable. Well, I'm going to divide by the coefficient. So my final answer is, yeah, good job. My final answer, Lissandro, 2/3. Nice. Now, can I turn that into a decimal? What is 2 divided by 3? Is that a nice decimal? It's what? 3 divided by 2 is 1.5. 2 divided by 3 is 0.6 repeating. We don't ever solve for a repeating decimal, so we're going to leave that as a fraction, okay? Fraction's a great answer. Last one. Are we all ready for the last one? Okay. Last one. Okay. So is there any distribution that's taking place here? No, but what do I need to do to eliminate the decimal or eliminate the fraction? Yeah, so I'm going to write a little note that says I want to eliminate my fraction. I'm going to draw a little arrow that says multiply by what, Lissandro?
2.
Just 2 over 1. Yeah, good job. So I'm going to write that out so I can see it. So I have 7x minus 5 all over 2 minus 6 equals 9. I have a question. Can I eliminate the fraction yet? What is next to that fraction? Minus 6. So we have to get rid of that minus 6 first. So we are going to eliminate the fraction by multiplying by 2. But first, we have to move the negative 6 to the other side by adding 6. So I'm going to leave that there for a second. So we have to get the fraction all by itself before we try to eliminate the denominator, right? So I'm going to rewrite this problem. So I have 7x minus 5 all over 2 minus 6 equals 9. And I'm going to do this step first. I'm going to add 6 to both sides. I have to do that first. So when I add 6 to both sides, that gives me 7x minus 5 divided by 2 equals 15. And now I can do what Lissandro said, which is multiply both sides by 2 over 1 or 2. Good job. That eliminates my fraction. 7x minus 5 equals 30. So now I'm at that step that says, hey, we want to get that variable all by itself. We want to get that variable all by itself because I don't have variables on both sides. So we want to isolate the variable. So what do I have to move away from the 7x? I have to add 5. Good job. Add 5. So now I have 7x equals 35. Last step says multiply or divide by your coefficient. So are we going to multiply or divide by that 7? We're going to divide both sides by it. Yeah, good job. And that means that x equals
5.
x equals 5. Perfect.